The Babylonian lunar calendar stands as one of humanity's earliest sophisticated timekeeping systems, blending lunar observations with solar alignment through innovative intercalation methods. Developed in Mesopotamia during the 2nd millennium BCE, this lunisolar calendar structured civil and religious life for over 1,000 years, influencing subsequent calendars across the Mediterranean and Near East. Its core innovation, the Metonic cycle, harmonized lunar months with solar years by inserting leap months at regulated intervals, a system later adopted by Greek and Jewish traditions. The calendar also introduced the 7-day week with rest days, concepts that persist in modern timekeeping. This report examines the Babylonian calendar's structure, intercalation mechanisms, cultural significance, and enduring legacy. The Babylonian lunar calendar originated from earlier Sumerian timekeeping systems, particularly the Ummah calendar of Shulgi, c. 21st century BCE, which organized months around agricultural cycles. By the Old Babylonian period, 1780s BCE, the system evolved into a lunisolar framework with 12 lunar months, each beginning at the first sighting of the crescent moon. Months alternated between 29 and 30 days, totaling approximately 354 days per year, 11 days shorter than the solar year. To resolve this discrepancy, Babylonian astronomers developed intercalation, the periodic insertion of a 13th month. Each month was tied to specific agricultural or religious activities. For example, Nisanu, March-April, marked the barley harvest and the vernal equinox. Adaru, February-March, concluded the year with the harvest of broad beans. These months retained Sumerian names but were administered in Akkadian, reflecting Babylon's cultural synthesis. Initially, intercalation was ad hoc, decreed by the king based on astronomical observations. However, inconsistencies led to the development of the Metonic cycle in the mid-8th century BCE, which aligned 235 lunar months, 19 solar years, within a 2-hour margin of error. This cycle mandated 7 intercalary months over 19 years. 6 years received a second Adaru, while the 17th year added a second Ululu. This system, formalized under Persian rule, post-539 BCE, shifted authority from kings to priestly astronomers, ensuring predictability. By 380 BCE, intercalation followed the Metonic cycle without exception, stabilizing festivals like Akitu, New Year, and maintaining alignment with seasons. The Babylonian week comprised 7 days, each associated with celestial deities. The 7th, 14th, 21st, and 28th days were evil days, Akkadian, Lemnu, requiring rest and rituals to appease gods. For instance, the 7th day honored Marduk, supreme deity, and Ishtar, fertility goddess. The 28th day celebrated Enki, god of wisdom, and Ma, mother goddess. These holy days likely influenced the Hebrew Shabbat, though scholars debate the connection. The term Shabbatu, Akkadian for full moon festival, shares linguistic roots with Shabbat, but Babylonian weeks were lunar bound, whereas the Jewish Sabbath follows a continuous 7-day cycle. Before 4999 BCE, the calendar relied on direct lunar sightings and royal decrees for intercalation, causing regional variances. The Mulapin tablets, c. 1000 BCE, provided early guidelines, linking intercalation to heliacal star phases. However, the Assyrian conquest, 911-609 BCE, centralized calendar administration, standardizing month names and rituals across Mesopotamia. Persian rule, 539-330 BCE, further systematized the calendar. Under Darius I, R. 522-486 BCE, the Metonic cycle became mandatory, reducing reliance on sporadic observations. Astronomers, Chaldeans, calculated intercalations using zigzag functions, a precursor to trigonometry, to predict lunar phases. The Babylonian calendar's influence permeated antiquity. During the Babylonian captivity, 586-539 BCE, Jews adopted month names, e.g., Nisan, Tammuz, and intercalation principles. Seleucid rulers, 312-63 BCE, rebranded it as Greek time, Anno Graecorum, spreading it to Egypt and Syria. The Islamic calendar retained the lunar framework but abandoned intercalation, creating a purely lunar year. Julian Chai Gregorian calendars inherited the 12-month structure and 7-day week, foundational to modern UTC time. Even today, the Jewish Rosh Hashanah, New Year, echoes Babylonian Nisanu's alignment with the equinox, while Gregorian months like April, from Apru, a later variant of Nisanu, trace etymological roots to Mesopotamia. The Babylonian lunar calendar was a cornerstone of ancient chronometry, harmonizing celestial cycles with societal needs through mathematical precision. Its intercalation methods resolved lunisolar discordance millennia before Gregorian reforms, while its temporal segmentation laid groundwork for universal week structures. As a cultural artifact, it exemplifies Mesopotamia's scientific ingenuity, facilitating agricultural planning, religious cohesion, and bureaucratic efficiency. Future research could explore its role in Mesopotamian astrology or its transmission via Zoroastrian traditions to Iran and India. Understanding this system enriches our appreciation of how ancient innovations underpin contemporary timekeeping.